We've also been discussing the mean and the median of these distributions, so let's think about the mean of these distributions in density curves. The idea of the mean in one of these distributions, in one of these density curves, would be like the balance point. If we think of this distribution as a physical object, where would it balance? Here's a basic diagram kind of indicating what we mean by this. If this is a physical object, if I move this fulcrum too far to the left or right, it won't balance. But once I find the point where it can balance along my fulcrum, that is my mean. So it is possible to find the mean on these, although it's kind of hard, to be honest, because it's hard to kind of visualize exactly where this balance point would be without being able to have a physical fulcrum and a three-dimensional object to try to balance it. But it can give us a rough approximation. The next question would be, how does this relate to the median? How can we find both the mean and the median from this? Here's a picture that kind of demonstrates that. When we're dealing with something symmetric, the mean and the median are actually the same, and they're right at the center. When I'm dealing with something that is skewed, the mean is further down the tail. So my note here, the long right tail pulls the mean to the right. If I had a long left tail, the mean would be pulled to the left. So either way, the mean is further down the tail. So now that we've looked at kind of the basic idea, let's see if we can do some examples of this. Here are three distributions with three different points marked, and I actually wanted to determine which one's the mean, which one's the median, and which one's the mode. So let's start with this one on the left. We can see that this is right skewed, so it has this tail to the right, which means the mean should be further down to the right. Therefore, C would be the mean. In addition, the highest point in this density curve represents the mode, so A would be the mode, and so then B would be our median. Before we do the second one, let's skip to the third one, the one on the furthest right. Once again, the highest bar is our mode, so that would indicate that C is the mode. We also know that the mean is further down the tail, and this tail is on the left, so the mean would be further to the left, so that would be A. A is the one further to the left, so A is the mean. And that leaves B to be the median. So now that we've done those, let's move to the center one, which is a little bit different. So first off, the mode is the highest point. We actually have two highest points here, so we actually have two modes. Both A and C would be modes. In addition, this distribution is symmetric. And in symmetric distributions, the mean and the median are the same. So B is actually both the mean and the median. Now that we've done that, let's end with just a little bit of notation on these. So far, we've been dealing with means and standard deviations, and we had symbols for those. X bar was our mean and S is our standard deviation. When we deal with density curves, these are not exact, they're approximations. But they're actually idealized approximations. It's what we would like in an ideal world. So therefore, their means and standard deviations are not perfect to our sample mean and standard deviation that we've been dealing with. Therefore, we have different symbols for them. The idealized mean is represented by the Greek letter mu. This is the mean of the density curve, this ideal mean that we have. The standard deviation of these density curves, the idealized standard deviation, is denoted by sigma. So we actually do have two symbols for mean and two symbols for standard deviation. X bar and mu for mean and S and sigma for standard deviation. And it can be very complicated to keep these two separated into which ones mean which. In general, everyday alphabet that we deal with the most often, like X and S, are our actual mean and standard deviation, whereas the Greek letters are our idealized. So mu and sigma are Greek letters, and so they represent our idealized mean and standard deviation, whereas X bar and S are part of the everyday alphabet, so those represent our samples and the things that we've been dealing with.